Hello friends, welcome back to my YouTube channel. Today in this video we will discuss multiple choice questions from rotational dynamics. Rotational dynamics is very important topic for your MBBS, engineering, A levels and all other type of competitive bachelor's levels examinations. Now let us start with questions. Before moving to questions, let us recall this formula. We have linear motion and angular motion. We have linear displacement and angular displacement. We have linear velocity and angular velocity. So let us relate this linear formula with angular formula. We denote x or s as a linear displacement, and similarly in a circular motion or in a rotational motion, if a body is rotating, it covers some distance in term of theta, in term of angle. From this theta angle is angle made by a body in a rotating motion between its two position, between its initial position and final position. Likewise, we have velocity. Velocity v represents linear motion and velocity omega represents angular motion. Omega is equal to theta by t. And acceleration, this a represents linear acceleration which is equal to v by t. But this alpha represents angular motion which is equal to omega by t. Likewise, we can change this all linear equations into angular equations. Our v represents final velocity in linear motion, but omega represents final velocity in angular motion. U can be converted, u can be changed into omega naught. So our formula v is equal to u plus at becomes omega is equal to omega naught plus alpha t. Our formula s is equal to ut plus half a t square becomes theta is equal to omega naught t plus half alpha t square. Our formula v square is equal to u square plus 2as becomes omega square is equal to omega naught square plus twice alpha theta. In this way, our linear mass, this m is called linear mass or linear inertia, and the same term becomes moment of inertia in angular motion. Then the moment of inertia plays the same role as mass plays in linear motion. And momentum, this momentum is made up of this momentum has two terms at last, this m and u. If you multiply this mass with velocity, we get momentum. This is linear momentum and this is angular momentum. And force F is equal to ma becomes tau is equal to tau, tau is equal to I into alpha. This work F into d becomes omega is equal to tau into theta. Likewise, our kinetic energy half mv square becomes half I omega square, and the formula for power F into v becomes tau into omega. Now let us recall this formula as well. We have moment of inertia of different object, and also the moment of inertia depends on the axis of rotation. So just make a list of this formula. If we can recall this equation and this formula, we can easily solve the questions from rotational dynamics. Now let us see question. Excuse me. Which expression is correct for moment of inertia? We know that moment of inertia I is equal to mr square. That mr square is in option choice C. Mass and square of the distance from the axis of rotation. That is option choice C is the correct answer for question number 1. Now let us see question number 2. Which equation is not correct? If we see this formula equation, then we can easily find the wrong among these 4 formula. If we see this formula, the wrong one is, I guess, option choice D. Option choice D, omega is equal to theta, t is wrong one, because actual formula is theta is equal to omega into t. Theta is equal to omega into t. So all other ABC formula or ABC equations are correct except D. In D we must have theta is equal to omega into t because omega is velocity, velocity is distance upon time taken, distance in rotational dynamics is theta. So this formula is incorrect. We must have theta is equal to omega into t. Now let us see this. Moment of inertia of a circular ring with mass m and radius r through its center and perpendicular to plane is. We must take care of this thing. This modify this term can see what is the axis of rotation. If we If we do not take care of these things, then we may reach to wrong answer, because this makes some modification in our final answer. If we are finding moment of inertia of circular ring with mass m and radius r through the center and perpendicular to the plane, this means for this ring our axis must be like this. This must pass through center and perpendicular to the plane. So for this case our formula is mr square. Our answer is mr square. Now let us see question number 4. A ballet dancer spins 2.4 revolution per second with her arm outstretched when the moment of inertia about the axis of rotation is I. With her arm folded, the moment of inertia about the same axis is 0.6 I. Calculate the new rate of spin. So in this case, a ballet dancer is dancing with her arm outstretched, and in second time she is folding her arms. So we need to find the spin or the rate of spin. In this case, we must use the formula. This formula is called principle of conservation of angular momentum. Here I1 omega 1 is equal to I2 omega 2, and omega is equal to 2 pi of, we know that omega is equal to 2 pi of, 2 pi and 2 pi will cancel. So I1 F1 is equal to I2 F2. Our F1 is here 2.4 revolution per second, and we need to find our F2. F2 is unknown for us, but our first moment of inertia I1 is I, and second moment of inertia I2 is 0.6 I. Second moment of inertia is 0.6 I. So cancelling this I and solving this equation will give us F2 is equal to 4. In this case we use this formula, and F2 is equal to 4 is the right answer, that is in option choice C. This type of numerical questions are also important for your entrance examinations. So let us move. Okay, now let us see this question. If Earth contracts to half its radius, what will be the length of one day? In this question, Earth is contracting to half radius, means its mass is same. Question is not saying about any mass, so we need to consider mass, Earth's mass is m, but our radius became r by 2 here. When radius decreases to its half value, what will be length of one day? Let us solve this question. See, considering Earth as perfect sphere, the I, moment of inertia of Earth, is 2 by 5 mr square. If its radius is contracting to half, then its moment of inertia becomes I by 4. It decreases to 4 times, because here our new I will be 2 by 5 times m into r by 2. M into r by 2, because our new radius is r by 2, and m by 2 r by 2 square will give us 2 by 5 mr square divided by 4, which will finally give us I by 4. So let me erase this one. So our new moment of inertia will be I by 4. Now using principle of conservation of momentum, I1 omega 1 is equal to I2 omega 2 or I omega. This I1 is I by 4, and this omega 1 is omega 1 right now, and this I omega is I omega. If we cancel I and I, we get omega 1 is equal to 4 omega. Omega 1 is equal to 4 omega. We know that omega 1 is equal to 2 pi by t1, and 4 is already there. Omega is 2 pi by t. Omega is 2 pi by t. 2 pi cancel, and we get t is equal to, or we can say that t1 is equal to, let me erase this one and I will write, then we get t1 is equal to t by 4. After solving that, t1 is equal to t by 4. Our normal day has 24 hours, but when Earth contracts to half of radius, it becomes t by 4. It means 24 by 4 will give, which will give us 6 hours. So 6 hours, option choice C is the correct answer for question number 5. This is very important question. Now let us move to question number 6. The center of mass of thin triangular plate lies on. Center of mass of thin triangular plate. In this case, in the case of this triangular term, triangular plate or triangular lamina or triangular sheet, our answer will be its centroid. C-E-N-T-R-O-I-D. Option choice C is the correct answer for question number 6. Now let us see question number 7. If there is change in angular momentum from 2 joule to 4 joule in 4 seconds, the torque will be, our torque is dl by dt, that is change in angular momentum to time taken. Change in angular momentum is here, it is changing from 4 joule to 2 joule. So change in momentum will be 2 divided by 4 is the right answer for this question. Change in momentum is 2 in 4 seconds. 2 by 4. 2 by 4 will give us 0.5. 0.5 is in option choice C. Option choice C is the correct answer for question number 7. Now let us see question number 8. The moment of inertia of a body does not depends on. The moment of inertia of a body depends on option choice A, that is mass of a body. It depends on position of axis of rotation, option choice B. It depends on distribution of mass, but it does not depends on angular acceleration of the body. So option choice D is the right answer for this question. Question number 9. The SI unit of moment of inertia is, we know that moment of inertia is equal to mr square. So what is the unit of m? Kg. What is the unit of r? M. So kg meter square is the right answer for question number 9. Kg meter square is in option choice C. Kg meter square. Question number 10. The SI unit of torque is, the SI unit of torque is Newton meter. SI unit of torque is Newton meter. Option choice C is the right answer for question number 10. Question number 11. The torque per unit inertia is, the torque per unit inertia is, we know that torque is equal to I alpha. Question is asking about torque per unit inertia. If I write tau by I get alpha. Alpha is angular acceleration. Torque per unit moment is alpha. Alpha is angular acceleration. Option choice D is the correct answer for question number 11. Now let us see question number 12. Which expression is wrong? Just we wrote torque is equal to I alpha and angular momentum is mvr. We know that angular momentum, mass into velocity into r. In angular momentum, the last term of angular is r, last term of two terms of momentum are m and v. So if you write these terms together, we get angular momentum. This is also correct. Rotational kinetic energy half I omega square is also correct. This option choice C, moment of inertia is equal to tau into alpha. This one is wrong expression. So option choice C is the wrong one. Question number 13. The moment of inertia of a big drop is I. If 8 droplets are from it, the moment of inertia of a small droplet is. This is also very important question. You have one big water drop. That drop has moment of inertia I. Now that drop is divided into 8 small droplets. The new moment of inertia, the question is asking to find the new moment of inertia. Now let us see. The moment of inertia of big drop is 2 by 5 mr square. And if this big drop is converting into small 8 drops, then new mass will be m by 8. New mass will be m by 8. Now let me write this one. Because of this font problem, some part is not there. The new volume of that small drop is 4 by 3 pi r cube. And if we gather this all small 8 droplets, we will get the big drop. So 4 by 3 pi into capital R cube must be equal to 8 into 4 by 3 pi r cube. Let me erase this and let me write it more clearly. We have this big drop. At first we have this big drop 4 by 3 pi r cube. Now it became 8 small drop. So this volume must be equal 4 by 3 pi r cube. On solving this, we get small r is equal to capital R by 2. So our r is r by 2 right now and m is m by 8. By using this small r and m in this expression, our m is now m by 8 and our r is now r by 2 square. By solving this, we get this 8 into 4, 32. This 32 I by 32. Our moment of inertia will be 32 times less than that of the original moment of inertia. So the right answer is I by 32. If big drop is converted into small 8 drops, the original moment of inertia is I, the final moment of inertia of each drop will be I by 32, because mass will be 4 times less. So mass will be 8 times less and radius will be 2 times less. On solving this, we get I by 32. Now let's move to question number 14. A rotating machine is maintaining a uniform angular speed of 150 radiation per second with torque 100 100 Newton meter the power is. We know that power is equal to torque into angular velocity. Our torque is 100, angular velocity is 150. On solving this, we get 50 kilowatt. That is option choice A. Question number 15. In rotational motion, the physical quantity that imparts angular acceleration is. In rotational dynamics, the physical quantity that impart angular motion is torque. Torque is the right answer. On changing angular acceleration, torque changes. So angular acceleration impart means it affects, it gives torque. So torque is the right answer for question number 15. Question number 16. A wheel of mass 10 kg has uniform moment of inertia of 160 kg meter square about its on axis. The radius of gyration is. For this question, radius of gyration, you must know the formula to find radius of gyration for all type of problem, and I have given this question number 16 and 20 as a homework for you. Just try to solve this question, but I have mentioned answer for this question. Write the formula for radius of gyration by yourself and try to find the answer. For this question, right answer is 4 meter. 4 meter is right answer for radius of gyration. Question number 17. The spoke are used in bicycle because spoke increases the moment of inertia so that we get steady and smooth motion. So option choice D is right answer. Both B and C are correct. So option choice D is the right answer for question number 17. Question number 18. If a body shrinks. If a body shrinks means we know that moment of inertia is mr square. If body shrinks, I decreases. If I decreases, moment of inertia also decreases. Option choice A is the right answer for question number 18. Question number 19. The position of center of mass of a particle is. Center of mass is the point where the mass of the whole system is supposed to be concentrated. So it must depends on the mass of the particle and their position. How far are they from the axis? So right answer for question number 19 is both A and B. Now question number 20. Question number 20, I already said that question number 16 and 20 are workout homework for you. Try to solve question number 20. Question number 20. For the question number 20, we can use the formula I1 omega 1 is equal to I2 omega 2. Thank you very much. And the right answer for question number 20 is 1.67. Thank you very much. Now just practice these questions and ask me what are the other different type of problems from this rotational dynamics. I will try to solve that questions in upcoming video. Thank you very much.